All right, let's get started. Hello, everyone. My name is John Rodriguez, and I work on the Cash App team at Block, formerly Square. I work on a library called Paparazzi. Just quick show of hands, who has never used Paparazzi before? Okay, cool. And who's never heard of Paparazzi before? Cool. All right, that's a good crowd. In previous talks, I go into the kind of innards of Paparazzi. I'm going to refer you to those talks mostly. I'm going to assume you've seen an example of Paparazzi before, just because that's what the past talks were for. And so the title of this talk is really going to be What's New in Paparazzi, focusing on what has been added or fixed since Joy-Con New York last year. What? Oh, it's at the end of the show. Okay, let me just fix that. Technical error. Cool, there we go. So for those who haven't used it before, and is your first time hearing about the project, the premise is really tightening the feedback loop between design and engineering. You may get handed a Figma, and you have to create your screen design, and you want to make sure, maybe you want your designers to be able to review the UI changes that you make on the fly, and right now traditionally you have to build the app and deploy it onto their device, or just show them, walk over to their desk if you still work in an office. The premise of things like Paparazzi is you could take a screenshot, commit it with your code, and then assert on them on CI. We didn't create it entirely from scratch. We essentially weaponized Layout Lib, or Layout Inspector, which has been a part of Android Studio for a really long time. And this is not even the most recent version of it, but it's still around. Layout Inspector is a powerful tool. In fact, it's what drives Compose previews. And so there's a library, Layout Lib, that is internal to Android Studio that we weaponize into a JUnit rule. And we will hopefully be able to get further uses out of it, as I'll talk about shortly. One of the major changes, though, that we made since last year to Paparazzi is hopefully something you'll never see. Paparazzi tries to, or rather Layout Lib tries to mock out Android. And part of mocking out Android involves loading all the resources that you would normally contain in your app at runtime, and then apply resource qualifications to it, such as your locales, your landscape, your portrait, in order to obtain a screenshot. During the Hack Week, though, when we created Paparazzi back in 2019, we took a few shortcuts that we had been basically tech debt paying back ever since. I filed an issue back in July 2022, hoping that essentially someone would be encouraged to try to tackle this problem. But coming into this year, someone from the team, Kevin, basically wanted a goal of trying to pseudo-localize our app. And so we worked together on this over the summer, and essentially got to the point where we're really happy with the resource reloading. And so I'm going to explain that in more detail. So this is when Paparazzi was born. And this is the resource repository object that we pulled from Android Studio test sources. It was really attractive because if you pass it a directory to where all your resources were located, it would do the job of recursively traversing that directory, loading the resources into this three-dimensional map, and voila, now you can query your resources. There was one bit of a problem in resources aren't all contained in one place. And so that whole, how do you pass it a single folder when you may have resources in your local module or in your transitive modules or in AAR. And I'll talk about how we doubled down on this hack in order to accomplish that. A note here, though, is that when we borrowed this class from the Android Studio sources, it was already deprecated. Yet we marched on. So what got interesting was a few months after we decided to use that deprecated class, Android Studio deleted the class upstream. They realized that Android Studio itself had moved on from this resource repository to yet another thing called resource repository, just a different namespace, and that the only consumer of the old resource repository was layoutlib in its test sources. And so it said, let's get this out of SDK common, which is being loaded by the IDE because we don't use this, and just move it over to layoutlib's tests. That makes sense? Dead code, why ship it? Except that we were really heavily depending on it. And so we ignored upgrading SDK common and a lot of dependencies for a while, basically 3 years, until Android Studio Dolphin came out. And a thing to know about Paparazzi is that layoutlib bugs become Paparazzi bugs indirectly. And so Paparazzi had a class of bugs that were ultimately being pointed to Android Studio's layoutlib bugs. And if you were on Chipmunk, right, before Dolphin, and you were eager to upgrade to the latest, this resource repository problem that we were sweeping under the rug was really starting to become a blocker. Yet still, we tried to live with it. We decided to inline the deleted classes into Paparazzi just so that we can upgrade to Dolphin. And that lasted us probably a good year. So before I go more into the internals of resource repository, it does help to talk about how Paparazzi interacts with resources a little bit. So layoutlib, this thing that I mentioned, this jar file, the bootstrap of layoutlib is this bridge class. It's mostly in Java or Kotlin bytecode. There is a native component, and so one of the things that Android Studio does when you install it will download, or rather, when you download Android Studio, you're downloading a machine-specific build because, well, many things in Android Studio, one of which is layoutlib, has a machine-specific implementation. And so Paparazzi handles that for you. And the bridge is essentially calling out via JNI to the native-specific version. So think of bridge as like your device. It's the thing that's going to load all the Android platform, the font libraries, the calendar details. Next comes session parameters. You're going to instantiate the session parameters and pass it to bridge. Think of session params as your app. This is the thing that's going to contain the content, route, your landscape or portrait configurations, any other things like min SDK, target SDK, and the specific resources included in your app. And so once you set that up, you will create a session. That is how you will take your snapshot to then pass either your legacy view or composable and get something like this. I'll talk a little bit later about how we manipulate the choreographer in order to obtain multiple frames, and when we talk about how Paparazzi will soon be supporting video. So going back to resources, or rather session params, we see that there's this parameter called render resources. This is how you're providing your resources to Paparazzi. And specifically a type of render resource called a resource resolver. Think of it as a glorified three-dimensional map. It looks like it's a two-dimensional map, but note that the value of the inner map is another map. So you have a namespace, say Android or app. You have your type, your layout, your string, your drawable, and then your value, which will be keyed by the actual resource name. And so once you have how do you actually create a resource resolver? Where you have to pass it both all your project's resources and the framework resources that are provided by the Android platform. And then you're going to scope them to whatever folder configuration. That's your resource qualifier. Are you landscape? Are you portrait? Are you US English? Are you in night mode? And so all those resource qualifiers are passed via that folder configuration to essentially filter down to a subset of resources that you are going to be looking up to take a snapshot. And so how do we get those resources, right? So you need, for session params, you need a resource resolver. Resource resolver, you need the resources. And so we're working backwards. In order to load those, we eventually need to get into the file system. And basically, Paparazzi is providing this bridge code. We have framework resources provided by, again, these deprecated classes. If you note the strike-throughs, these are the deprecated classes that we're talking to, and they were very attractive because of the fact that, again, you could pass one single directory and it'll do all the work for you. And Paparazzi would then have to figure out, how do we get the platform directory and the res directory conveniently for the user? And these are the values specifically that we're talking about. So during the hack week, we created a Gradle plugin that you're probably familiar with, and we hook in a special task into the Android Gradle plugin's task graph that says, hey, before you compile Kotlin code, I know that you're going to merge resources. I am a task that will be listening for the output, as well as listening to the output of the assets merge task. And it asks, hey, where are you going to write all the resources? And so it says build intermediates. Great. We write that to a file. And the reason why we do that is because we don't want the Paparazzi JUnit rule itself to know that Gradle was doing the work for it. That's to keep a clean boundary so that if, say, Bazel plugins or some other build system plugin were to exist, Paparazzi itself could still go on relying on essentially system properties. And if it isn't clear, that build intermediates res merge debug is the directory that we were taking advantage of. We found out by looking at AGP sources is that, oh, you don't need to get the transitive dependencies resources yourself because AGP will just merge them into that directory for you. So that directory will have not only your local resources, but it will also have copied over all the AAR dependencies into that folder. So moving on, now that we have that file, as I mentioned here, when you're running Paparazzi, it will know to look for this golden file that has all the data that it needs to load the Android platform. So how does this look in the code? Well, this is how the Paparazzi plugin does it. It looks directly into the Android Gradle plugin's sources and says, give me the merge resources task. And it's even grosser for the merge assets tag, and you can see why. You now lend yourself to being broken every time you bump the Android Gradle plugin. If the Google team decides to name that from merge resources provider to something else, or if the name of the task is changed, which is very common in any refactoring, you've now had to keep up with every version bump in the Android Gradle plugin. So we know this wasn't great, but again, we waited 3 years to change it because it just worked long enough. You may have wondered why Paparazzi only works in library modules or had worked in only library modules. Well, a direct corollary of depending on the merged the merged resource directory is that it's only text-based in a library module. In application modules or dynamic feature modules, those resources are merged into a protobuf flat file format because APT will eventually package these up and bundle it into your APK. So that's the reason why we hadn't been able to support up till now. So if it wasn't clear, we really should never have been looking in the res merge debug directory. We really should have been looking in the direct location where these resources were located. But needless to say, that takes more work because now we're not looking for one folder, we're looking for all the folders. And how do we get that information? So yet again, we go back into the Android Studio source and we see how complicated they actually do it. It's actually not part of the Android Studio source. It's kind of part of the IntelliJ source in the Android plugin suite, but that's just semantics. At the end of the day, there's a singleton service loader architecture to IntelliJ where the Android support plugin, the thing that makes essentially IntelliJ powered to be Android Studio, it provides their DI where you look up the resource repository, and IntelliJ will rely on the PSI model. Now, if you've never written an IntelliJ plugin and maybe are not familiar with the PSI model, core to IntelliJ's way of parsing all language and source files is by crawling through source like so and coming up with an abstract syntax tree. If you've ever written a lint check, if maybe you've dealt a little bit with Kotlin symbol processing, this syntax is somewhat familiar to you. So IntelliJ will, at runtime, while you're modifying a resource, will update its in-memory model of your resource tree. Now, IntelliJ needs to do that because it's an editor, so you might be typing or updating or deleting resources on the fly. Paparazzi doesn't need that, right? When you're running the command, it's essentially static. So we started off by copying that that hierarchy from IntelliJ, but pruned it back quite a bit because none of the virtual file system or PSI bloat that IntelliJ employs was needed by us. So how does this look? Well, IntelliJ has this concept of a resource folder resource repository, which essentially maps to what you would think, the folders where your resources live in your local module. There is also a resource repository account for dynamic resource values. So you may know that you can create resource values in your build.gradles dynamically, say your git SHA or git commit timestamp. And so there is affordance for that. Those get grouped into a module resource repository, which, as you would think, would be your Gradle module. Then there's a project resource. Did I lose Mike? Okay. Then it groups into your project resource repository, and that's representative of your repo. However, this is all managing source, either in your local module that you're building against, or in its transitive also local modules. You'll need another repository to account for the AARs, which are going to be downloaded via Gradle into somewhere in your cache folder. Okay, so moving that aside, I don't know what happened there. Moving that aside, if we look at how the plugin used to query this code, now the question is, where do we get these paths now? Where do we know where source main res is? We don't want to hard code it because that'd be bad. We don't want to poke into the Android Gradle plugin's internals to do that. Well, it turns out the Android Gradle plugin does provide these facilities, but through a more robust API. You can query the Android Gradle plugin for artifact types. And so if you ask it for resources and filter it by essentially what's in your project and what's not in your project, and the Android Gradle plugin will provide you those directories. And if it changes over time, you won't break. You just keep the same API. And so that resources.txt from before, we push all that information into that file now saying, hey, these are your local modules. The order does matter because of resource overlaying. If you define the same resource label in both the main and debug directory, you do expect the debug variant to override the main. That's a very crucial part of namespaces, resources, especially if you do not apply namespacing. And so we needed to account for that. And then we point to folders that happen to be in the Gradle cache because we use Gradle. But if, for example, you were using Bazel or your own build system, any pointer to where the unzipped res folders in your respective AARs live would work just fine. And so that's kind of the high level. We don't need to really kind of dig into the code of how, other than just knowing that that's the new architecture we're on. And in doing so, we saw through initial profiling that we've immensely decreased our heap usage. So this makes sense. We were kind of using just test sources and moved into what the IDE uses, which despite what your day-to-day development is, the IDE does try to be a little more memory efficient because of all the things it has to handle. And so the fact that it dropped by that much was an unanticipated but nice win. Now that we no longer look into the internals of merge res, Paparazzi can be used in application dynamic feature modules now. It just points to the actual textual resource locations. Inadvertently, we hadn't realized that there were bugs in the old system that we just hadn't come across. But if you were using string plurals or xlif tags or HTML tags in your string resources, they may not have worked, and now they do. And also by not pointing into the internal details of AGP, but rather finding the folders where these resources would live, it potentially makes it easier to migrate to, say, a Bazel plugin. As alluded to earlier, one of the motivations to finally move over to the new resource repository mechanism was to enable pseudo-localization. Internally, we've been working on internationalization efforts as we hope to launch in an additional country soon, and so there's a whole lot of work behind that. And so pseudo-localization is something that we wanted to try in order to, until we get like our translation framework underway, just to detect some of the design issues that may come up from having maybe higher text field heights because of diacritics, or what if we hard-coded strings where we shouldn't? What if we were concatenating strings or formatting things in a way we shouldn't? How will bidirectional text problems look like in right to left if we're using the correct start and end versus left to right Android semantics? If you aren't familiar with pseudolocalization, there's a facility in Android that allows you to enable this pretty simply. If you just enable this in your build script and compile your app, followed by going into your languages settings area in your app, in your device, you can add a language, 2 extra languages, one that maps to the accented pseudolocalization locale and the BIDI pseudolocalization locale. And if you enable either one, you should expect the app to be restarted through a configuration change and look something like this. The middle one being the accented form, and the right side being the BIDI form to represent Arabic or Hebrew style languages. And so one may wonder, how does this actually work? So if you're used to already having translations in your app, you may be familiar with adding the locale qualifiers to your values folders. And so this is a little more text about what these actual there are 2 additional locales that are provided as a result, and these are their names for your values folders. And so what typically happens is when you pass that setting to your build.gradle file, AAPT, which is the part of the Android Gradle toolchain that will compile your resources, merge them, convert them to proto, and eventually bundle them into your APK, will run over all your resources and do just that. And one step that I hadn't really noticed until this exercise is that it will check to see if that flag was set in Gradle. And if it was, and you are not a do not translate.txt or a string resource that is flagged as do not translate, or a segment of a string that is demarcated with an xlif tag, so if you're using placeholders in a string, you wouldn't translate those, then you will be pseudo-localized. It'll essentially run through all the resources for the default locale and add 2 more strings by transforming them through an accented and BIDI format. And so what does that look like? Well, I'm not going to go really deep into it, but just so you know, it has to look at things like style strings, your plural strings, and your basic strings, because at the end of the day, it's dealing with strings. And it'll do something sort of like this, where it'll detect which character is being currently used and map it to a Latin alphabet character equivalent that has a diacritic, so like a rising accent, a decreasing accent, maybe an umlaut, where it's still it's still legible, but you know that it's not US English style. It'll also, if you enable the BIDI representation, add in Unicode characters that can override the directionality of a word. And so if you've ever moved your cursor through something that's bitified, you'll notice that as you go from left to right, it'll some point stop and move the other direction, which can be frustrating if you don't know what your left traversing and right traversing cursor movements are. But that's what that explains. That essentially BIDI characters are being injected into the string to coerce it to be a right to left language style. And so another thing I should call out is that this is how AAPT does it to crunch it in your APK. LayoutLib does not use AAPT. And so there's a lot of extra work that Paparazzi and LayoutLib has to do in order to kind of pretend it's doing what AAPT is doing. And so we just stole it. We just copied from Android Studio into Paparazzi and realized that if we can just figure out how to update our new resource repository magic and basically integrate into the entry points, we can localize it to use the same AAPT logic. And that's what we're doing. So let's see this in action. We've primarily been rolling with the accented pseudolocalization locale. We haven't yet employed the BIDI one in our app. So it looks something like this. Lots of diacritics and extra spacing, and that's the point. You want to see how your UI reacts to, say, languages that are known for having really long words, not calling any particular language out. I think we know which one it is. Here's another example in a widget-based format. As you can see there, we may want to reconsider whether we want that data ellipsized, or do we want dynamic font scaling, or what? It's something for consideration. This is exactly the point of why you may want to consider pseudo-localizing your app. Now, one thing to point out is this is going to pseudo-localize string resources. If you get a lot of your string information from server, Paparazzi will not help you here. However, one thing that we did write internally is an extension function that attempts to introspect any model object and crawl it for strings, unless we apply an annotation that says, do not translate this, for example, if you're a server opaque token and therefore it makes no sense. You may want to consider using something like this yourself in your testing so that you can get full test coverage. Otherwise, you'll expect the developer to, in their test files, pseudo-localize it themselves, and typically it's not a good idea. So how does this all look together when you combine both the pseudo-localization and the new resource writing stuff? We have a sample in Paparazzi that I invite you to look at, but it's still as simple to set up as any other Paparazzi test. And here's how some sample resource lookups appear today. String plurals was one thing I called out. So in English, you use the one and the other plurals aspect. So string plurals internationally has up to 6 cases. And so basically what we call in US English your singular and your plural, but other languages have suffixes for 2 of a kind, or 0 of a kind, or many of a kind. Arabic in particular uses all 6 plural types. And so it was a nice way to test both BIDI and whether we were doing string pluralization correctly by employing Paparazzi tests on the Arabic language. Okay, so let's talk about some other things that we fixed. So while we created Paparazzi, Android Studio came up with the idea of compose previews, which brought some pretty robust feature sets, and that made us basically desire, can we take this to the next level? One small thing that we did add over the last year was the ability to no longer require taking snapshots of your whole device screen. If you want to test a widget, you can now, just by supplying a render mode. We previously also required you to set the system UI to false, but then we realized no one really wants the system UI, so we've inverted that Boolean to be always off unless you really want it on. And so combining those two things now make a previous screenshot that had a whole lot of real estate that made no sense to being something a little closer to what you probably wanted, a widget snapshot. What are we talking about here? So for this, gift card stuff, right? This is, sorry, I'm looking at an example. Right. Sorry, I had to take a little cheat about what I was talking about here. And so one of the other things that we notice is previews on Android Studio are a really nice thing for developing on the fly. But then as soon as you finish developing your previews and creating your view, you probably follow up with just writing a Paparazzi test right away, which seems duplicative in effort. You kind of set up your preview, you liked it, now you're doing the ceremony again just so that you can have this Paparazzi test. So one thing that we started to look at is, can we take a preview and add an annotation to it and automatically generate your screenshots for you? We originally thought that by adding this annotation, we were going to generate the test sources for you. But then one limitations of how KSP actually works, and peeking ahead on how Android Studio is looking to do something similar, we decided that as long as, well, I'm kind of revealing my hand, but in terms of right now, Paparazzi is a JUnit rule. If we can extract that into something like an SDK, where it's no longer bound to be a JUnit rule, maybe we can apply this annotation and generate screenshots just directly from your previews, and you never have to write a test again. It also will save us the need to map all of the Android Studio's team's preview parameter types that may evolve over time, having to map them into Paparazzi-specific types. We've started work on that as of yesterday. I won't say that it wasn't motivated by this talk. And we are going to continue finishing that up, hopefully this quarter. Deadlines are hard in open source, but we are committed to getting that done soon. Another thing that we've come to notice is that sometimes your views just don't render exactly when you want it. Sometimes this is developer error. Sometimes you're caught using a launched effect in a composable view, and you realize that there's just nothing more that you can do. But one of the things that we tried to work around is adding this instant animation rule that will, all right, if your view takes multiple frames to render, let's just jump to the last frame. This is a bit imperfect, though. It was a nice try. It doesn't work for Compose, and it heavily depends on you using Animator, because then you can reflectively set the animator's values for the purposes of a test. So while it's nice if it works, it hasn't been bulletproof. We also have this function called GIF that we haven't popularized it much. It's kind of broken. It's not really supportable in a sense, but it exists. It kind of works for legacy views and not really for Compose. Until recently, we started to double down on this. A teammate on my team, Chris Drury, has been working on an animated ping writer from scratch, following the animated ping spec, using OKIO and multi-platform. And we have pretty good confidence that soon we'll be able to take a video that looks something like this. I don't know if that's an autoplay. Hopefully it does. Yep. Okay, so that's like a mock video. And then what if you change it to rotate the other way? Well, now you'll be able to do paparazzi video diffing as well. You may have noticed in the previous slide when I was talking about the paparazzi annotation, this mention of Picasso. Yeah, we still use Picasso on Cash App and in Block. And so we've recently made Picasso Compose supportable and fakeable and even coroutine manageable. And it works really nicely with Paparazzi. In fact, if you look in the Picasso repo, there is a Paparazzi sample that will show how you can integrate with that. We haven't publicized the fact that we've been publishing alphas because it's way too early to really be confident, but if you are interested, it's up there and start playing around. It's still being actively maintained. Of course, writing a Gradle plugin wouldn't be fun if it didn't have its fair share of Gradle bugs to kind of learn on the fly. And so some of the things that we fixed since last time, well, that's one of them. Here's a bug that we found in the field. And so if you write Gradle plugins on your own team, you may find this particularly interesting. It turns out that the bug for this problem has nothing to do with fonts, despite the stack trace. And here's why. So as you saw, we were using this way in the old way, and still to a certain extent in the new way. And so in the Gradle plugin definition, we decided this is the directory, so where else would we save it to other than a directory property? And because we use Gradle remote caching and we want to be efficient, we wanted to do a relative path. We don't want your user's home directory to be remotely cached only so that your fellow coworker will have no use for the cache because they don't have your home directory. And so we implemented it that way. But it turns out that while that's what we expected, the path sensitivity enum and directory properties themselves don't work quite the way we thought it did. Here's what the enum class types are. And here's what they actually mean. It doesn't look at the file path itself. It looks at the contents inside the directory. And so we had this nasty bug where if you built your module in debug mode and release mode and they were exactly the same, there was no debug variant resource that appeared in one versus the other, the Gradle plugin would inadvertently think a debug build was a cache hit for the release build, and it would populate the release build in that resources.txt. And so now when you're loading fonts, it goes, oh, I'm going to look in your release directory for the fonts, and actually you were in the debug directory. The other one didn't exist, and that's what crashed the fonts. So silly me, I wrote that code. It turns out that instead of using proper type safety in Gradle, you should just use plain old strings. Another fun Gradle bug to figure out is if you work on Gradle plugins, particularly in Android, you have to be aware of Android variants, such as the debug and release stuff. And so originally our reports were being written if you basically ran build, you would first run test debug and then test release, and the report from test release would overwrite the report from test debug. Oops. As a result, when you were running Paparazzi tests twice in a row with no changes, you still ran the whole test suite, which that's silly. That's what Gradle, up-to-date checks are supposed to do. And so we've since fixed that. This is basically what I said, not good. And then with the change here, by just adding variant to the directory name, we go from here to there, and now we're happy. As I mentioned, we have a first-class Gradle plugin. We have talked about maybe having a contribution, maybe from a company well-known, doing a Bazel plugin. It's still maybe coming soon. I hope that we can, at the very least, get contributions from the open source community out towards this. We've also added some new things to our accessibility suite in Paparazzi. In case you weren't aware, Paparazzi does provide you a way to check accessibility compliance in your app. And your composables too. So now, basically, oh, right, that's the point. We now support compose. We previously didn't. That's the point. And so now, here's an example of how that looks. If you, for example, didn't set your content description or didn't group certain things in a certain way, and it will be surfaceable and noticeable as is. It tries to employ the same logic that, say, TalkBack would use to determine accessibility compliance. One thing that's also hidden in the source of layout lib is the ability to validate your layouts. And so we've surfaced that in Paparazzi as well. If you provide this validate accessibility Boolean, and you had a text view where you accidentally made your text color the same color as your background color, therefore not being able to see the text at all, you should get an error message like this. Besides the fact you'd probably get a screenshot that would seem like an empty box, but yeah, that helps too. This does not work for Compose at the moment, but that's a layout lib thing. Hopefully they will be able to surface that soon, and we can make use of it. We've also added support for Android Google Wear. That's adding new device configs thanks to a contribution from Sohan at Google over in London. And so with those device configs, we can get something like this. And then finally, Compose multi-platform. There's a lot of talk about it, and I talked briefly about it in last year's DroidCon talk, and I wanted to just give a quick update on that. So a lot of our screens are server-driven. We have this idea of a form blocker. You've also might have seen Jake and Jesse's talk at a previous DroidCon about Redwood and Zipline and Treehouse. And so the idea is that while the UI views on each platform will be responsible for having a native look and feel, the schema of what drives either platform can be driven by server. And so the previous iteration of this was something called Form Blocker. And so it was a common pain point for both our server team and our design team to see, hey, we set up this proto to describe this schema. How does it look on your device? And they have to install emulators and all that. And one of the premises of Paparazzi is not having to do that. And so we think, can we employ this for more than just unit testing? And so we've been working on porting this website into a Kotlin a Compose multi-platform app, WYSIWYG app, where server engineers can drop proto definitions. It's very business specific, so we're not sure how much of this will be open sourceable. But you drop your business logic or your proto in here, and it'll automatically render how the Android device would render this using Paparazzi. And that's it. Here's the repo. Please, if you haven't used it, continue to use it. If you haven't updated to the latest and tried the new resource loading mechanism or pseudolocalization, please try it out and file issues, and we'll be chugging along in the meantime. Thank you.